guys, this is Will with SRT Amplification, and in this video we're going to look at a voltage doubler circuit and how it is used in a guitar amp from the 1960s. We're going to first take a look at the prints, and I'll explain to you kind of how the voltage doubler circuit works. And then we'll actually take voltage measurements on an actual amplifier. So if this piques your interest, stick around. And if you haven't already, subscribe and hit that like button. Again, I thank you for watching these videos and supporting this channel. Enjoy the video. Alright, so welcome to the bench. In this video we're going to look at a power supply that a lot of lower line, inexpensive economy type of amplifiers used back in the 60s for whatever reason, whether it was to, make things cheaper, or maybe the world was moving towards solid state low voltage type of amplifiers without tubes, and they just started using these transformers. I really don't know exactly what the reason for this is, but it's something that you may see in these early to mid 60s types of amplifiers. This is the power supply section. I've kind of enlarged it. It's of a greater schematic here of a Silvertone Model 1484 guitar amplifier, otherwise known as the Twin 12. At first glance, you may look at this and think this is like a full wave rectifier because of the two diodes coming off here on both of these windings. But in actuality, what this is setting up here on both of these windings is a voltage doubler circuit. And I was just wanting to go over with you a little bit about how this voltage doubler circuit works. Typically, you can distinguish this from a full wave by the fact that the diodes are going to be pointing different directions. One's going to be pointing, the arrow's going to be pointing towards the winding, and the other one's going to be pointing away. And you'll always have two capacitors in here as well in the voltage doubler circuit. And you can see it's the same on both of these windings here. So a little bit later on in the video, we'll actually take voltage readings on here, and I'll show you that what the AC voltage is on this side and then what the DC voltage is on this side. But just to kind of go through how this kind of works, since this is AC on the primary here, you kind of have to take this in an instance in time. So if you look at the positive iteration first, and if we just polarize this winding right here, put our positive up here on the top and our negative on the bottom, and if we use conventional current flow, positive to negative, that's going to set this up to where this side of the coil is going to be more negative, or this side of the winding is going to be more negative than this side. So that's going to forward bias this diode right here and allow current to flow. That current is going to flow and charge up this capacitor, positive and negative, with whatever voltage is on there, in this case right around 120 volts. On the negative iteration, this is going to flip. Okay, and you're going to have negative up here, or positive up here. And what that's going to do, it's going to forward bias this diode, and we'll have current flowing in this capacitor, positive to negative, about 120 volts. And the same thing happened at the same time on this winding right here. So basically what you ended up with after a full sine iteration is these four capacitors are charged up to about 120 volts each, DC. And that should give you right around this 480 here that it shows on the prints. Okay, we'll see when we do this up. This is probably going to be a little more than 120 volts because this is based off of 117 volts coming in from the wall, and I've got about 122 coming in from the wall, I believe. So it's going to be a little bit different, but we'll look at that. But basically that's how this voltage doubler works. It's basically stacking up. If you could just think of these capacitors as 120 volt batteries each. It's just stacking them up, and your reference is from this point right here, and this point is actually tied back to the common point on the schematic, which is right here. So you see it comes up here and it ties to here. And so you might ask yourself, well, what about this capacitor right here? Won't it add to it? Well, no, because this is the common point, and you can see this capacitor's in here backwards. It's got the positive here, the negative here. This is your actual negative bias cap. Okay, so this is sitting up your negative bias. So this is like a whole nother rail. Basically, we have a positive rail of 480 volts, and then we have a negative rail here of, I don't know, probably 20 or 30 volts or whatever it is. I can look on the other part of the schematic here, see what it is. Don't remember. Negative 36 volts here is what the negative bias is. So get that in the frame. Yeah, negative 36 volts right there. That's setting up your grid bias for your output tubes. So that's why this capacitor is not adding to that 480 volts for your B+. So let's look at those measurements on the actual amp itself, and maybe you'll get a little bit of better understanding of how this is all adding up. And then I can button this thing back up and I can get to playing on it. Let's look at the amp. Okay, so I got the actual amplifier up here on the bench, and this is the 1484 model 1484 Silvertone head that I got from Uncle Doug here a while back. I did an unboxing video of it a couple of videos ago, but I thought since I had it up here, I had to change out the filter caps anyway, that I might as well just take some readings to kind of go along with what we talked about on the schematics. So let's look at what we got coming in first on our line voltage, and I'll just go right over here to our power switch, and that's 124 volts, 124.8 volts there. So that's what we got coming into the unit. Now, as we talked about in the schematic, this circuit, this amplifier uses on the power supply, uses a voltage doubler circuit. So it actually has a smaller voltage on the secondary side than on the primary. And then it doubles that voltage, and it actually uses 2 split windings. And so we're just going to get a few measurements here. On the AC, if you went across the coil on the AC side, or the winding, I guess you would say, you're going to see about a, let's see, well, let me find out where it's at here. Whoa, 93 volts, right? 93 volts across one of them, 93 volts across the other one, and that's RMS. So you're actually getting less AC on the secondary side. That's RMS, so you're probably going to look at about, let's go across the capacitor with DC, flip it over here. We're going to get somewhere up around 125, I believe, something like that. Should, let's see here. So that's one cap, so 122, 121.8 DC. Across the next capacitor, we're getting another 121.9. Across the other capacitor on the other winding, $123. I got my leads backwards, 124. And across the other one, 122. So they're reading a little high. All 4 of them are supposed to add up to 480 according to the schematics, or excuse me, 460 volts, I guess. 480 volts, yeah. So we're getting a little higher than that, but that's based off 117 volts on the input. So yeah, so we're reading probably right around 490 all the way across them. So let's see what I get when we go across the whole, all 4 capacitors here. So it should be this one and this one, 489. So right at 490. So we're a little bit over, and that's because of the increased primary voltage that we have. So that's how the voltage doubler works. I just thought I'd give you some measurements there so you can actually see it in action. And Hope you enjoyed this video.